Okay, welcome back to the YouTube channel of Kendall A. Smith. Today, I want to talk about coronavirus again. It seems like it's never too far away from the news. But before I get started, I want you to just remind you to like the video on the YouTube channel and click on the bell so you get notified for when I do another one, usually once a week. And then also scroll down on the YouTube site and you can find my website and my social media links and so forth. So the big news in the last week or so has been the Omicron variant. And so I thought I should talk about this, even though there's a lot more yet to come in terms of data as to what this so-called variant is all about. And one of my pet peeves is the use of the term variant as opposed to mutant. I figure it's time that the populace of the world begin to understand molecular genetics and understand what a mutation actually is, and know about DNA and RNA and all that stuff. So I just refuse to call them variants. I call them mutants because the Omicron mutations, a horse of a different color than the Delta and the Alpha and the Beta and so forth, because they in one of the publications that I saw there was a picture of the spike protein, the actual molecule with all the atoms in place and so forth, and they colored the mutations, and there's all kinds of, at least 20 or so right in the top of the head of this protein. Whereas before, the variants have been not necessarily in spike, but in other aspects of the virus. And as soon as I saw that, I said, this is not going to be a good one. And now, the other thing about this whole mutation business is that in order to find the mutants, the variants from the isolates in the community, the virus has to be, the isolates have to be sequenced, which means that there's four bases that make up the code of the DNA, and they have to sequence the whole strand so that they know where a mutation has occurred, because it's usually, not necessarily always, but usually a single base that has been substituted for another. And RNA viruses have a much higher mutation rate than, say, DNA viruses, and particularly if it's a double-stranded DNA virus. Because if they're two strands, and if I'm not mistaken, coronavirus is a single-stranded RNA, so there's nothing to check the fidelity of the copying when the gene is copied in, so that you can get two viruses out of one. If a mistake is made, there's no way to check that, and most RNA viruses don't have the machinery to go ahead and detect any mutants and then replace a misplaced base pair. That all happens in our cells, and so the rate of mutation in the human is much lower than it is in something like an RNA virus, and even in other mammals and so forth. So that's just a little bit of Kendall's molecular genetics. So the Omicron mutant has got a whole bunch of mutations right in the spike protein. And of course, the vaccines that they rushed to get out a year and a half ago were specific only for the spike protein. So the material that was injected into everybody either has the spike protein already prepared, or has the gene sequence for the spike protein, so that when the gene sequence gets into cells, it produces the spike protein. The coronavirus has 29 different genes. If you give only one of the genes in your vaccine, it's going to make it easier for that virus to mutate around it, to get around the immune system. Because what happens is that the immune system sees that spike protein and starts making antibodies, which are soluble molecules that float around in our bloodstream and so forth, and bind on to that protein. And in the process of doing that, they tag that protein, that whatever the antibodies are bound to, and other cells come along and gobble up the complex of the virus as well as the antibody and clear it. the virus. That's how it works. Now, there's other parts of the immune system that are also involved, the so-called T cells. I don't want to get too much into the weeds. We can talk about T cells in another instance. But if you have 29 different genes that are part of your vaccine, rather than just one, stands to reason that you end up with a vaccine that's broader in scope, so that a single mutation or a single problem in the sequence of the virus as it gets inside of you isn't going to be so easy to get around. Anyway, so the Omicron variant mutant doesn't look good. The other problem is that in the United States of America, we didn't mobilize early on our molecular geneticists and put them in a room and ask them to cooperate with one another. In stark contrast, that's what they did in the UK. And the molecular virologists, geneticists got together early on, like March of 2020, and said we have to really ramp up the whole system so that we can sequence viruses as fast as we possibly can. And so it had to be a huge cooperative effort with multiple labs all over the country and so forth involved in the whole thing. And in addition, they needed money, funding to support all the stuff that they needed to do and buy the reagents and the equipment and so forth. The government in England came through for them. So they had funding, they had cooperation. And I'm told by one of my former trainees, Doreen Cantrell, who is now a well-established professor in Dundee in Scotland, she really attributes a lot of this to the women that were involved as molecular geneticists, because they're in contrast to the males that they can cooperate with one another much more easily than the males. If you put 5 male mice in a cage, they basically just try to kill each other. And so they bite each other all over. And you come back in a week and you look in the cage and you can find that there's one mouse who's completely unscathed. And then a couple of mice that have got some pretty severe wounds on them, but not too many. And then the last 2 mice are basically doomed. They've got bites all over them and so forth and so on. So those are the male mice. You can put 5 female mice in a cage and they're fine. They don't do that to each other. So that's just part and parcel of the whole problem that I think the world has to deal with. So the UK scientists they're way ahead of everybody else in the world. And so what you need to do in terms of following this Omicron mutant is to watch the news. And they've already come out in the UK saying that the Omicron mutant is doubling every 3 days. And they predict that by the new year, I think it is, that they think that 50% of the isolates in the UK are going to be Omicron. So that's just what we've got to look forward to, because if it happens there, it's going to happen here. And throughout this pandemic, we've been 2 to 3 months behind Europe and the UK in terms of what's been happening as far as how the mutants have been raging through the communities. And the other thing is that I don't know whether you've been watching it, but if you look at Europe has absolutely gone bonkers, because particularly like Germany and Austria, the rate of new cases per day is higher than it's ever been, higher than it was in the very beginning. And they haven't come out and said what's going on there, but I can't help but think it's either Delta that is raging through the unvaccinated people, or it's Omicron, or maybe even other mutants that we haven't even discovered yet that are responsible for the rapid uptake in new cases. And so they're overwhelming the medical systems in Germany and Austria and others. And so all you have to do is look back through the history of this pandemic and you realize it's going to happen here to the good old US of A. It ain't going to be good, because what's going to happen then as a consequence is that the governments are going to have to try to deal with the pandemic in sort of the old-fashioned way, before they had any vaccines or drugs or anything to help to combat the virus. And they're going to have to get back to public health measures. I wanted to talk a little bit about that. The difficulty with this particular viral infection is that humans are the vectors. In medicine and epidemiology and so forth, we talk about in terms of very contagious infectious diseases. We talk about a vector, and for example, malaria. The vector that's carrying the disease are the mosquitoes. The mosquitoes are not causing the disease. Rather, when they bite you and they inject their venom into you and so forth, they inject the parasite that actually does cause malaria, and you get it into your body and it starts replicating and so forth. And that's the whole thing. So one of the things that the public health people did early on, when they finally realized or discovered that malaria was the vector in malaria was a mosquito, you get rid of the mosquitoes. That's a no-brainer. It's the same thing with yellow fever. Yellow fever is caused by a virus that's carried by a mosquito that causes hepatitis, and that's why they call it yellow fever, because the people turned yellow. It's in the same family of viruses that cause hepatitis C infection, which is one of our more modern plagues. And so the thing is, the first thing that they did at the turn of the last century, a really good investigator in Cuba, Finley, first started to say, I think the vector in this instance is a mosquito. And that came to pass. And Walter Reed was an army doctor at the time stationed down there. And he's credited with a lot of the proving essentially that it was due to a mosquito. And so then you clean up the stagnant water where the mosquitoes are breeding and so forth and so on. That's public health. That's prevention of disease, which is in my last video. I really defined what public health was rather than personal health. And those are the two issues here. Because what goes on and what's going on now in the United States, where we have at least a third of the people who are unvaccinated, that creates a huge reservoir of people, of potential vectors, that if they get infected, if they get exposed to the virus, and that's easy to do because it's in the air, and in particular in bars, restaurants, and inside places. So we're going into the winter months here in the United States. That's just a setup to just breathe in the virus, and then you're infected. And then these little guys replicate really fast, and so they're just constantly turning over really rapidly. And every time they duplicate their RNA, they can make a mistake. They can have a mutation. So it's a big reservoir of the human beings that are the vectors, and they can generate mutants galore, essentially. And that's a problem because the other people, let's say 2/3, are already vaccinated against the spike protein, only one gene. What's going on is the survival of the fittest virus, a la Darwin. So if a mutation happens in just randomly, because that's how it works, in an infected, unvaccinated person, then that virus and the progeny of that virus, if they infect another person who is already vaccinated, well, the vaccine, the immune response to the vaccine will deal with 99.999% of the viral particles that come from the unvaccinated person. But there's that 1 out of 1 million that it's already mutated in the first person. So it gets into the vaccinated host, but the immune response won't help because it's mutated around that. And that's the fittest virus, the Darwin's survival of the fittest virus. And so in this vaccinated host, well, that's a selective force like par excellence. So that virus just replicates up the gazoo, and now you've got an outbreak on your hands, because then that is transmitted to another person because of all these asymptomatic infected people that are wandering around. And you can see why we're not going to get out from under this pandemic easily, given the state of our society. And it doesn't even have to be, it doesn't even have to be a problem that's only in the United States. The Delta variant came from India, and ostensibly the Omicron variant mutant has come from Africa. So it's a worldwide problem. And if we don't wake up and start looking upon this whole situation as a global situation, we don't have a chance of getting out from under all of the constraints on our public freedom, which impact, and this is what all the business people are worried about, impact on our economy. And of course, when I've talked about this with some of my friends and so forth, and they say, well, can't they just make a new vaccine to the new mutant variant? And the answer is yes, but it takes time, and not years like it used to with these RNA vaccines, like I discussed in one of the other videos. They can make a new vaccine, but now you're playing whack-a-mole, okay? So now, and it takes time to vaccinate, billions of people. It doesn't happen overnight. And so, yeah, we can play whack-a-mole with new vaccines and so forth, but ultimately we're going to need to make, from the genome of the virus, we're going to have to identify genes and gene products that would be better vaccines, because if mutations happen in that particular gene, that would be lethal to the virus. So that you can't. So those are conserved sequences that are necessary for the so-called fitness of the virus. And, this has been talked about in HIV and all the other different kinds of infectious diseases that we've dealt with. And ultimately, they're going to have to do that. But that all takes time and lots of scientists. So finally, I want to re-talk about, I've been thinking a lot about, since I made the last video on coronaviruses, about the public health versus personal health situation. Because my feeling is that our so-called officials haven't really educated the populace. And I said that before, because what really needs to happen so that you can have public freedom of movement within the public, meaning any place there is groups of people besides two, you're going to have herd immunity. And in this particular instance, because this is an aerosol transmitted through an aerosol, it's very, very contagious. It's like measles and smallpox, as I said before, because all you need to do is breathe it in. And so I think this whole business with social distancing is a lot of hooey. You don't want to be kissing people, but anyway, because it's so contagious and transmitted through aerosols, you're going to have to build up so that the population is greater than 90, maybe even greater than 95% have been vaccinated. Because then, if you introduce somebody who's infected into the society, there's going to be no susceptible victims for the virus, for the vectors, and so it won't cause an outbreak. The outbreak won't become an epidemic, and the epidemic won't become a pandemic, because there are no susceptible hosts, or very, very few susceptible hosts. And I think more and more people need to talk about this. There has to be a mandate for, if you want to participate in public life, you have to be vaccinated. Other countries are beginning to do this, and to say, okay, you can't go to work, you can't go to school, you can't go to bars and restaurants, you can't go to the theater, you can't do anything. And I'm waiting for some societies to say, okay, you're out of here. We don't want you. If you're not vaccinated, we don't want you in our society. So they can deport you. I guess a little bit Nazi-oid. But that's what we're looking down this tube here. I think those are all of the points that I wanted to make. I'm looking down at my notes now, and so I'll leave you with that. In order to have public freedom, we need to get all vaccinated. And the important thing about these vaccines that have come out for coronavirus is that, by comparison to other vaccines that have been used in the last couple of hundred years, or last 100 years, these are really innocuous in terms of side effects and problems from the vaccine itself, by comparison to a situation where we need to have no public freedom. We have to have total lockdown, like in China, and also like in Australia and so forth. So I'll stop there, and thanks for tuning in. Don't forget to like the video and click on the bell and check out my other online sites to see if you can find anything else that you might be interested in that I'm also interested in. So thanks very much. It's been fun. Thank you.